Yo, what's up YouTube? It's Kia the Cat with a video discussing inequalities. Today we're going to look at what they are, how to graph them, and how to solve them. Let's get right into linear inequalities. Linear inequalities are equations that show a range of solutions rather than one or more points in regular linear equations. In order to understand linear inequalities, you first have to understand how to solve and how to graph linear equations. Luckily for you, I already made a video talking about this, which you can see in the top right of your screen, also linked in the description below. So there are four types of inequalities: greater than, less than or equal to, greater than or equal to. Each one has their own distinct sign. So for number one, greater than, anything to the left of it is greater than anything to the right of it. So let's say we have x is greater than 7. So x would be greater than 7. Less than. So anything on the left side of this sign is less than anything to the right of this sign. So let's say x is less than 10. So x would be less than 10. Number 3, less than or equal to. So any value of the left hand of this symbol is less than or equal to any value of the right hand of this symbol. So if x is less than or equal to 20, then you put x simply less than or equal to 20. And greater than or equal to is simply the opposite. So as you can see, the symbol is flipped around. So anything to the left of this symbol is greater than anything to the right of this symbol. So if x is greater than or equal to 20, you would simply flip this symbol around. A few things to notice. For anything that's less than or equal to or greater than or equal to, you'll see this little line under it. This simply means or equal to. And what less than or equal to actually means is that any value of the left hand of this side is either less than this value or it's equal to this value. So it can be either or, and that's what these signs mean. Okay, now let's look at graphs of inequalities. First, let's look at greater than and less than inequalities. So the first thing I want you guys to notice is that for greater than and less than, we have this dotted line. What this is showing is that all our values shaded are our solutions, not including the values on this line. That's why it's dotted. If this line was solid, then the actual line would include our solutions. So first, let's talk about greater than. When we see a greater than equation, all of the solutions are above the line. So as you can see here, all the shaded solutions are above our dotted line. For less than, all the solutions are below our dotted line. So as you can see here, all solutions shaded in are below this line. Now usually this line is shown as a linear equation. And usually the equation will say x is greater than whatever. So if you see a graph like this, whether it's on the SAT or in your math class, you know if the solutions are above or below, then you can tell if it's greater than or less than. Also, if the line is dotted, or if it's a solid line, then you can tell whether the line includes the solutions, or whether we have a greater than, or a greater than and equal to. Okay, let's look at our next two graphs of inequalities. So here we have greater than or equal to, or less than or equal to. The main difference between this graph and the ones we looked at before is the line. As you can see here, both our lines are solid. This means that every point on this line is a solution. If you remember last time, our lines were dotted. This meant that all our solutions were shaded, but this actual line did not contain any solutions. However, everything else is the same as the greater than or less than equations we looked at before. So all our solutions for greater than or equal to are going to be above this line, and all our solutions for less than or equal to are going to be below the line. Okay, let's practice finding the graphs of inequalities. For these two graphs, I want you guys to go ahead and find the equation of each inequality of each graph. Feel free to pause and resume to check your answers. Okay, first I'm going to start with this graph. So the first thing I want to do is look at the line, because the line is going to tell us whether we have just a greater than or less than, or whether we have an equal to symbol under it. Now, like I said before, whether the line is solid or dashed will tell us this. Because this line is solid, we know we have an equal to symbol under it. Now we have to determine whether the solutions are above or below the graph to determine whether we use the less than or greater than symbol. Because the solutions are under this graph, we know we're going to be using the less than symbol. This gives us the inequality of less than or equal to. The next thing I want to do is find the equation of this line. We know this is a linear inequality, which means this is a linear equation. This means we can use slope-intercept form to find the equation of the inequality. Doing so, we're going to have y. The next thing we have to do is find the slope. I'm going to pick 2 points. I'm going to pick one here and pick one here. Now we just have to find the rise and the run of these 2 points. Right here, we have a rise of 1.5. This is scaled differently, so here we are going to have 2, 3, and 4. Going up 1.5, we have 1.5. 1.5 is equal to 3 halves. Here we have a run of a half. Doing rise over run, we have 3 halves over a half. Now if you don't know, to divide fractions, we simply multiply by the reciprocal. So I'm going to have 3 halves multiplied by the reciprocal of 1/2 is 2 over 1. These 2's cancel out, and we just have 3, which is our slope. So we can put that in our equation. Lastly, we have to find our y-intercept. Our y-intercept right here, as you can see, is -1. So we'll just put -1. This is our equation of the inequality of this graph. Let's see if we got it right. As you can see, we did everything correctly. Now let's look at this graph. So remember, our first step is to determine whether we have a greater than, less than, or equal to sign under our inequality. Because this line is dashed, we know we're just going to have a greater than or less than. To determine which one to use, we're going to look at where the solutions are. As you can see, everything is shaded above our line, which means we're going to be using the greater than symbol. Next, we're going to find the graph of this line. Doing so, the first thing we're going to do is find our slope. I'm going to pick 2 points along this line. I'm going to pick 0, 2 and 1, 4. Doing rise over run, we have a rise of 2 and a run of 1. Rise over run is 2 over 1, which gives us a slope of 2. So our slope is 2x. Next, we need to find our y-intercept. As you can see, it's 2. This should be the equation of our inequality. Let's see if we got it correct. As you can see, we did everything correctly. Okay, let's look at some inequality equations. So these are essentially linear equations, but there's one rule you have to memorize. If we divide or multiply by a negative on both sides of a linear inequality, we must flip the inequality sign. Here I put a quick example to show this. So here we have 2x plus 1 is greater than -4x plus 3. Let's say we want to solve for x. So obviously the first thing we will want to do is get the constants on one side. So if we subtract 3 on both sides, we get 2x minus 2 is greater than -4x. Next, we want to get our variables on both sides. So we can subtract 2x on both sides. Doing so, we get -2 is greater than -6x. Now here's what we're talking about. In order to get x by itself, we have to divide either -2 or -6 on both sides. Because we're dividing by a negative, we're going to have to flip the sign after we do that operation. So here we divide by -2 on both sides. As you can see, we flipped our inequality sign and we get 1 is less than 3x. Now we can divide by 3, and because 3 is not negative, we don't have to flip our sign, and we get 1/3 is less than x. This is heavily tested on the ACT, and this is where a lot of kids get questions wrong. So make sure you memorize this rule. Okay, let's practice solving inequality equations. I want you guys to go ahead and solve for x for each inequality. Feel free to pause, and when you get your answer, feel free to resume to see if you did your steps correctly. Let's start with this equation right here. We have -3x plus 1 is greater than 7. The first thing I'm going to do is subtract 1 on both sides. This gives us -3x is greater than 6. Now I'm going to divide -3 on both sides. Because I divided by a negative, we know we have to flip this sign. So here I'm going to have x is now less than -2. Here's our answer. Check in. We got that right. Here's our next equation. Let's do this. Here we have 8 is less than -5x plus 2. I'm going to subtract 2 on both sides to get constants on one side. We have 6 is less than -5x. Dividing by -5 on both sides. Here we have to flip the sign because we're dividing by a negative. So now we're going to have -6/5 is now greater than x. This is what x is equal to. Checking our answer. We got that right as well. Okay, let's talk about systems of inequalities. So systems of inequalities are almost the same thing as systems of linear equations. However, our solutions now cover an area instead of a point. Now, to solve systems of inequalities algebraically is the same thing as solving systems of linear equations algebraically. I already made a video discussing this, and you'll see it in the top right of your screen right about now. It's also going to be linked in the description below. The one thing that differs though is when we try and find our solution graphically. Here, the area that both graphs cover shows all the possible solutions to our equations. Let's look at some examples. Okay guys, let's practice. For the set of equations and graphs, I want you guys to go ahead and find the area of which the solutions are for each of these two equations here and here. Feel free to pause, and when you get your answer, resume to check and see if you got it correct. Let's start with this graph. So we know that where the graphs go ahead and overlap is where our solution set is. As you can see, this part is all white, which has no solutions. This part is all red, which has no solutions. And this part is all blue, which has no solutions. This overlap part over here is where our solution set is going to go ahead and be. What I want you guys to go ahead and realize is that any point inside here, whether it's right here or right here, is going to satisfy both these equations. So if we go ahead and solve algebraically, both of these points would go ahead and fit perfectly fine, and we would get the same answer. Also, I want you guys to notice that this is a dotted line, which means that our solutions do not include this line. So any point, I say right here, or even right here where the lines intersect, is not a solution to this set of inequalities. Let's look at the second graph. Here, here, and here is all one color. But here where the graphs overlap, this is where our set of solutions are going to be. Just like the other set of inequalities, as you can see, we have no equal sign under these two. This means that we're going to have dotted lines, and that these lines are not solutions to the set of inequalities. So points like here, or even here, are not going to be solutions to the set of inequalities. I want you guys to make sure that you go ahead and remember these patterns for inequalities and the rules for solving them. The SAT loves to put these questions and test whether or not you understand how inequalities work. As long as you memorize these rules and the patterns inequalities have, you'll do great on your SAT or in your algebra class when you go over linear inequalities. Alright guys, that's the end of inequalities. This isn't a very complicated set of concepts to understand, but it's going to be very important for all you guys taking those standardized tests later on. Make sure you like, subscribe, and keep on learning. Enjoy the rest of your day, guys.